In this short video, we're going to look at the first section of data analysis, which mainly covers how to take an average and how to do a standard deviation. You should already remember things like the strengths of lab experiments, the weaknesses of lab experiments, and different methodologies used in case studies. So easy replication in lab experiments, what is low ecological validity, methods used in case studies, case histories, interviews, questionnaires, diaries, observations, experimental tasks. The weaknesses in case studies being generalization. We'll look here at central tendency and dispersal, which, as I said, is mainly just looking at means, medians, modes, and standard deviation of data sets. So, there's some fancy looking terminology here. Once data has been collected, it must be analysed. There are lots of ways to do this. You can look at the measure of central tendency, you can look at the measure of dispersal, you can look at correlation, and you can use graphological or graphical representations, because that's an actual word. So measures of central tendency. At the University of St Andrews, there are 150 people with an annual salary of £12,950 and 4 individuals with salaries of £250,000 a year. And the principal professor, Sally Mapstone, earns 550 grand a year. Were you to take the average of these salaries, what would you find? You would find the average salary is £22,532, a salary that nobody gets. This is not really a fair estimate or a fair representation of the salaries. This is well above what the vast majority of people in this university earn, and is brought up by the individuals over 250,000 and the principal professor. So we look at different ones. You'll come across this in simple mathematics. So the difference between means, medians, and modes. So the measure of central tendency attempts to get the middle or the actual average value of a set of data. It's a basic analytical technique only. There's 3 different terms you would use for average. So you should probably have an idea of what the difference between means, medians, and modes are already. So mean is calculated by taking all the numbers and adding them together, what we call the sum, and dividing by the number of numbers, or n. So sum over n gives you the mean. The median is calculated by putting the data in rank order and finding the middle number, or if there are 2 numbers in the middle that are dissimilar, finding the mean of those numbers. And the mode is the most common digit to occur in your data series. So summarise these below what I've just said into page 24 of your booklet. I'll pause. Right, summarise this. Measures of central tendency, so if you can work out the means of these. So I haven't done this in advance, but 2, 2, 3, 5, 5, 7, 8 is 4, 7, 12, 17, 24, and 32, and 3, 6, 7, whatever that is. It's about 4. Probably added the numbers up wrong. And then we have 3, 5, so it's 8, 17, 21, 26, 37, 47, 52, 59, 66, 70 something, 4, 84, 96, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So 96 over 13 is whatever that is. So 4.57. Median is 5, because obviously the median number is here. And the mode is 2 and 5. You've got equal modes because there's 2 very similar numbers. The mean here is 7.38, which sounds about right. The median is 7, because if you rank these numbers, 7's in the middle. And the mode would be 5, because you have 1, 2, 3 numbers for 5. Measures of dispersal. So measures of dispersal attempt to see how spread out data scores are. You can use the range, which measures the spread of the data. So if you have, for example, the previous numbers, 2, 2, 3, 5, 5, 7, and 8, your range is between 2 and 8, which is 6. It's calculated by subtracting the lowest from the highest score. For example, the scores 12, 23, 8, 31, 17, 19, and 27. Your range is between 31 and 8, which is 23. So working out the range of these numbers, it looks like the lowest number is 3 and the highest number is 11. So your range is 8. Good. What is range of limited value? If we're looking at the dispersal of salaries in Morningside, a very swish area of Edinburgh, it's where I used to live, not Boston, I'm just saying. An average Edinburgh suburb might have a range of say £50,000, but in Morningside we found a range is 1.4 billion. That probably means that there's some houses there that are incredibly expensive, but there's also probably a more deprived population in Edinburgh. So range is of limited value. Outliers can skew your results. So if you take out J.K. Rowling's house, which looks like this, which apparently is worth several billion, but doesn't look that nice, it really skews the results. So a better method is to use what's called the standard deviation, where we find the mean of a data series and then look at the general distance between each data value and that mean, and then see how much variation you actually have. So if the standard deviation of a group score is large, that means that there's a lot of distribution around your mean. So some of the scores are very far away from that mean value. If the standard deviation is small, it means that most scores are very closely gathered around that mean. So there's a clip that will be in the attached PowerPoint that you can use. So it actually is quite simple. Luckily, there is no examination where you, as a psychology student, need to calculate the standard deviation in an exam. I have not checked, but I can almost guarantee that you can Google standard deviation in Google, and there'll be some program that will just do it for you. But you should have a basic understanding of how it works. You calculate a mean. We've already discussed how to do that. You subtract the mean from each data point. So that means if you've got a number that's higher than the mean, you'll get a positive number, and if you've got a number that's lower than the mean, you'll get a negative number. You then square the differences, where that means that your positive numbers stay positive but are squared, and your negative numbers become positive and are squared. So a deviation from a mean of 5 to data point 8, so you have a deviation of 3. But if your mean is 5 and your data point is 2, you have a deviation of negative 3. In both cases, when you square that value, you get 9. Doesn't matter if you start with a positive or a negative 3. That's the beauty of a standard deviation. It shows just deviation, not a positive or negative. You calculate the average of the squared differences. So you've got your mean. For each individual data point, you subtract the mean from the data point, square that difference, and then you calculate the mean of the squared differences. Take the square root of that number, which seems like a very circuitous method to get something, and that will then be your standard deviation. So work out the standard deviation for this data set: 5, 7, 11, 2, 4, 5, and 8. When we do this, we calculate the mean. So 5 plus 7 plus 11 plus 2 plus 4 plus 5 plus 8 is, of course, whatever that is. I was hoping a number would come up. There are 1, 2, 3, 4, 5, 6, 7 values. So it must have added up to 42 if that number sum over n gives you 6. For each value, you calculate the deviation from the mean. So 5 will be a negative 1, 7 will be a positive 1, 11 will be a positive 5, 2 will be a negative 4, 4 will be a negative 2, 5 will be a negative 1, and 8 will be a positive 2. See if Mr. Gollier can do basic maths. Yes, he can. Look at that. So it's talked about before, we're going to square the deviations from the mean. So you can square these numbers. So a negative becomes a positive. So you get 1, 1, 25, 16, 4, 1, and 4. It then wants us to take the mean of the squared differences. So 1 plus 1 plus 25 plus 16 plus 4 plus 1 plus 4 over 7. So we've got the same number of values as before. N gives you 7.4. So it must have added up to whatever that is, like 50 something, 51, 52. And then we're going to take the square root of that number. So the square root of that number is 2.7. So we'll say around 3. So our mean, if we remember initially, our mean was 5. No, our mean was 6. So the mean is 6, but the deviation around that mean turned out to be almost 3. So that's quite a lot. That's about half of the mean. So that's not an amazingly great data set, a lot of the values are quite spread out around the mean, so you've not got a very tightly grouped set of variables. Why the standard deviation is useful, it really shows you how spread out your values are. Obviously, this is mainly used in a quantitative survey. Qualitative data doesn't necessarily need us to do standard deviations. So all of these have a mean of 6, but as you can see, the spread of the variables, values around it are completely different. The difference between two groups is statistically significant when the difference in selection rates is greater than two standard deviations. So a standard deviation of -1, -2. If you compare two groups and you look at the differences, and the differences when you take the standard deviations are 2 jumps, then it means that there's a significantly statistically difference between the groups. This simply means that the observed difference is probably not due to chance. Okay. So we can look through these examples. The mean IQ of a general populace is 100. The standard deviation is 15 in most IQ tests. Therefore, 68% of the population will score between 85 and 115. So the deviation here, 15 and that's either side. So you've got 100 plus or minus 15. 95% of the population here, you can see two standard deviations. So that's 70, because that's two standard deviations of 15, or 130, because you can see from this graph, it looks like 68% of people are between one standard deviation and 95% are between two. Anyone scoring below 70 or above 130 is significantly more or less intelligent than the general populace. So you can have a go at these summary questions just to see if you get it. If you don't, you can listen to my 12-minute video of how to do means, medians, modes, and standard deviations. I can almost guarantee there are better resources on the internet, so do feel free to Google that. Make sure your notes are up to date, and if you've got any problems, feel free to ask Mrs. Valsinger for help. Go through the answers.